In this video, we're going to learn how to merge two sorted linked lists. So let's say you have linked list given as 1, and you have given 3, then 5, and then it's null. So this is our first linked list. And second one is given as 2, then 4, and then 6. And it's pointing to null. So we have this given, and we know these both are sorted. This one is sorted, this one is sorted. And our new linked list will gonna look something like this. 1, then 2, then 3, then 4, 5, and 6. And pointing to null. So in the quotient, this will gonna given and this will gonna given, and we need to make this up into this linked list. And this merged linked list should be also sorted. So how are we gonna do this? Okay, let's go step by step how we can do this. So we can see here that this, okay, like if we point our pointer here, our first pointer here, then if you see this thing that this one is smaller than this 2. Okay, so we know this thing that this 2 should come here after this. Okay, but we're not gonna do that. We're gonna move ahead. We're gonna remove this. Okay, now we move ahead here on this one. Now we compare again. We see that this 3 is greater than this 2. And now we know this 2 should come before 3. So we can simply write here that 1, then 2, and then 3. Okay. Now this one is done. So this is done. Now our pointer will gonna move to 4. And we're gonna compare again. Now this 4 here is greater than this 3. So when you see that something in the second list, like the number in the second list is greater than the number in the first list, then you simply need to move ahead. So as soon as we found out this one is greater, we're gonna move this pointer here. So after moving the pointer, it looks something like this. We can remove this and we can simply point it here. Now we're gonna compare it again. 5 and 4. So now we can see in the second list, this one is smaller. So whenever you find smaller one in the second list, you just need to put that before where it points to in the first list. Like the pointer points here on the 5, and you found out this thing that in the second list, 4 is smaller. So it's simply just gonna substitute this here. Okay. So you're gonna do this. 4. And then 5. Now as this one is gone, now we came here on this 6. You see this thing that we're gonna compare this again, and we found out this thing that the 6 is greater. 6 is greater than 5. So whenever we're gonna found that in the second list the number is greater, we're gonna move this ahead. And now it became null. Now the pointer points to null. The pointer points here. Right. As soon as we find out this thing that the pointer that we had declared is pointing to null, we can just end the loop. So it's done. Okay. Simply just take the second list wherever the pointer in the second list points to and just add that up on the back side of this. Okay. So we're gonna take this here, and we're gonna add this simply right in the front of this 5. So you're gonna look something like this. 6 and null. So you see that how we comparing each and every value from the first list to the second list, and that's how we are able to generate this new list. Well, this is not a new list, this is actually the list 1. We just modified it, right? Let's take another example. That one we're gonna clear things more. So let's say we have 2 this time in the first list, and then 5. Then we have 6, 8, and then null. I really hate it. So in the second list, let's say we have 1, then we have 7, and that's all. So we have only 2 numbers in the second list. Now how are we going to substitute these values into this list 1? Let's see that. So at first we're going to declare some pointers. Well, firstly the pointer going to point here, another pointer going to point here. Then the second thing that we do is we compare this value to this value. So we find out this thing that this 2 is greater than 1. So in the first list the number is greater, and whenever we find the number is greater, as soon as we find the number is greater, we just simply substitute that the number in the second list to the back side of that number in the first list. So we need to fit this 1 here. But there's one problem. We cannot fit this here. Because, like, if you see here in this our previous example, let's take that again, our second list again. We were having 2, 4, and then 6, and it was pointing to null. Right. Now, whenever we were trying to substitute this value over here, we were having an account for this node and this node. That's how we can actually put this here. Without this previous node, we cannot substitute a value of another list, we cannot substitute any other node here in this list. So how we actually do this? So let's say this is our previous pointer. We declare this previous, and let's say this is our current 1 pointer, and this is our, let's say it's current 2 pointer, right? So if you want to substitute this current 2 in here between the previous and current, you do something like this. You make the previous next equals to current 2, and then you make the currents 2 next equals to current 1. So that's how you substitute the value, right? You should know this previous. Without this previous, it's gonna become difficult to put these values here. Because if you don't use this, if you simply just go for current 2 next, then you will gonna lose this node right here. So you should have the previous pointer. That's what we're gonna do here. But in this one example, we don't really have pointer. We don't have anything here because this is our head and the list is starting from here, but we need to put this value before this. So in this one example, we can see that we need to substitute this 1 over here, but we don't have any previous pointer. There's nothing, there's no node here which can like this previous pointer points to. So to sort this out, we basically just take a dummy node. We declare a dummy node. Let's say it's 0 inside of it, and or like a negative value, and we just simply assign that as a previous. So we do this, like we can just simply declare a dummy node like this. It's like list node star dummy equals to new list node 0. Okay, that's how we declare a dummy node, and we can just simply make this dummy node, we're gonna attach this dummy node to the first list. So dummies next is equals to head 1. So let's assume that the head of this is head 1. So we're just attaching the dummy node to here. So it's gonna look like this. This is 0, and you can take any value, like take a negative value or whatever. Then after this, you can simply assign this value right here in the middle, right? So this is the value, and you just have to put it here. So let's assume this is our previous pointer. We have to take this as our previous pointer. This is our previous, and this is our current 1. This is our current 2 pointer. So now we can simply do this, that previous next is equals to current 2, and our current 2's next is equals to current 1, right? So we can, this will gonna substitute here then. So our new list will gonna look like this: 0, then you have 1, then you have 2, and 5, 6, 8, and null. Okay, so this one is our previous, and this one is our current 2, and this one is our current 1. So we can rub this for now. Now what you need to do, that you need to compare this current one again with the value here. But there's one problem here. If you notice that we have lost our connection after when we shifted this value right here, we lost our list. We were not having any pointer ahead of this current 2 which points to this list. So like we have, it's removed here. Now we don't know, like we haven't declared any pointer for this list. So to save this list and to check for further nodes, we need to declare something. So we're gonna declare a pointer here. Let's say this is the second pointer. Okay, so we can declare our second pointer as list node star second equals to current to next. So we were having our current 2 here, which was 1, and this was our current 2, right? And current to next is this, so this is our second. Now we know we need to compare this. So we can simply say this thing that, and we need to remove this current 2 here, because every time we're just going to compare the current 2 to this current 1. So now current 2 is already in this list, and we need to shift this current 2 here. So to shift, we do current 2 equals to second. Now this second here will gonna become current 2 now, and the second will gonna move again. Second will gonna become the currents next, and the currents 2 next, like this one is current 2, and currents 2 next is null, so second will become null in the second iteration. Okay, so we can remove this. This one is our second now. And now we're gonna compare this again. So now this is our new list. Our current 2 is gone from here. This is our new list. Now compare this current 1 to this current 2. And if you're gonna find out this thing that this current 2 is greater. As soon as you find out that in the second list the number is greater, we just move ahead our pointer in the first list. So this current 1 will gonna move to 5 now. So you can remove this current 1, and now this will gonna move to 5. This one is current 1. And now this previous also needs to move, and this previous will gonna move, this previous always gonna be behind this current 1. So we can remove this previous and we can put this behind this. And if you're gonna write this in code, then how you're gonna write this, let's see that also. You move the current 1 ahead, so you move the previous first. So you write like current 1 was here, you know, the current, you know, this the current 1 was here, so you can simply write here that previous is equals to current 1. Previous will gonna move to the current 1 position, and the current 1 will gonna move 1 step ahead. So current 1 will gonna be current 1's next, right? This is gonna be our list now, and we need to substitute this current 2 in this list. So firstly we're gonna compare again with this new value of current 1. We find out this thing that this 5 is smaller than this. I mean, the number in the second list is still greater. If it's still greater, we're gonna still move this ahead. By using this same, we move this ahead. This is gonna become our current 2, and this 5 will gonna become our previous. Previous always gonna follow current 2. Okay, we're gonna compare again this current 2. Sorry, this one is current 1 actually. Current 1. So now we're gonna compare this current 1 to current 2. And we can see this thing that this is still greater. It's still greater. We're gonna move ahead again. So we move ahead again. It's current 1. This is going to be our current 1 now. And this one is going to be our previous. We're gonna compare again. This current 1 is this current 2, right? We're going to compare again. The 7 is now smaller. As soon as you find the number is less than the number in the first list, you're simply going to substitute this value right here. That's why we had this previous and the current 1. So now this will going to take the place, and it will going to look like this. So you know how we do this, right? So you can take here that previous next is equals to current 2, and this current 2 next is equals to current 1. Okay, and now our list will gonna become like this: 0, then 1, then 2, then 5, 6, then 7 will gonna come here, then 8, and then null. Okay, now as soon as like this current 2, like we know this thing, the second is null. If the second is null, our current 2 actually became null. At first it was here, the second was here, we know this thing, the second was here. Now the second move ahead when the current 2 became this node. Okay, so current 2 next is second, the current 2 next is null. That means the second is null, so the current 2 became null, right? If the current 2 became null, we're gonna stop our loop. So we can just simply stop our loop here, and this is going to be our final answer. Well, there can be two cases, okay? It is possible that it is possible that the current 1 can become null, and it is possible that current 2 can also become null. In both of the cases, we're going to end the loop. Like if any of this becomes true, we're going to break the loop. And why that so? If the current become null, if the currents 2 become null, you know that the second list is empty now. Okay, so if there's nothing left, you don't need something to add. If the current 1 became null, it means in the first list, every element is checked up. Okay, the current is here now, current 1 is null. So what you're going to do is that if there's any element left in the second list, you're simply going to assign all of the values on the back of this last node in the list first. So let's see how does a whole code will actually going to look like. So at first we know this thing that we need to declare some pointers here. So we're going to take the list node. Our first pointer will going to be our current 1, which will be pointing to the head of the first list. So let's say the head of the first list is list 1, and we need another pointer which will be pointing current 2, which will be pointing to list 2. So list 2 is the head of the list 2. We need another pointer which is the previous pointer. Okay, and we need a dummy node. Dummy node is actually very important. I told you why. So dummy equals to new node, new list node, new list node, and we're gonna put 0 inside of it. And after that, we need to make this we need to attach this dummy node to the head of the first list. So to do that, we're gonna write dummies next is equals to list 1. So list 1 is the head of the list 1, so we can do this. And after that, we need this previous to be our dummy node. Like we need our dummy node to be our previous at first. So we can simply assign the previous equals to dummy. So this is all about the declarations of our pointers. Now we're going to start our loop. Okay. So I told you that we need to run the loop until the current 1 is not null, and then until our current 2 is not null. If any of this becomes null, we can just simply end our loop, because if one of them becomes null, that means that our one of the list became empty now. All checks are completed. So the first thing that we actually do is we need to save our next node in our second list. So we know we have to do list node star second equals to current 2's next. In the second list, we need to save the next node after the current 2. Okay, otherwise we're going to lose the connection. And we need to compare the data of the current 1 and the current 2. So to do that, we're going to start our if loop, which will going to go something like this, like if the current 2 data, the val, is less than or equals to current 1 val value, then you need to do simply. It's like if in the current 2 the value is smaller than in the current 1 in the first list, then simply we're going to assign that current 2 value in the current 1. We substitute that. So for substitution purpose, we do previous next is equals to current 2, and our current 2 next will going to be equals to our current 1. So this will going to substitute the current 2 value inside of the first list. And in the else loop, else if, like in the else loop, like if you finds out this thing, the data is greater, then you simply need to do, you just simply need to move ahead. Then you have to assign, we have to make the previous the current 1, and the current 1 will gonna move ahead as current 1's next. So if you finds out this thing that in the second list the value is greater than the first list, then you simply need to move ahead previous and current. Okay, this is how our codes look like. Okay, now you need to know this thing that when you did this thing, when you assigned the previous next as current 2, current 2 next as current 1, you need to make this current 2 go back into its own list. So in the second list, it needs to go back. So for the purpose of making it go back, we do something like current 2 will gonna become second. Because we know this thing that the second is actually holding the value of the current 2 next. So if we need to move ahead this current 2 and we need to make it go back into its own list, we can go for this thing. Current 2 is actually second. So this will gonna do that. So this is going to be our full code. So after exiting this while loop, you have two possible cases. This while loop would have exited maybe because the current 1 became null, or maybe because current 2 became null. If the current 1 became null, that means that the current 2 have some value left. And if the current 2 is null, that means that our comparisons are over and our current 1 list is what we want as an answer. So So you can write this as, so if you find out that the current one is equals to null, that means that the second list have some values left. So you just simply need to assign those values, because if those values are left, that means that they are the values which is greater than the last node in the first list. Just assign them on the back of it. So we know this thing that we are ending our, if current one is null, that means and there is a previous pointer that we declare which is just before our current one. So we can simply say that our previous next, make it equals to current 2. It will gonna attach the rest of the part of the second list to our first list. It basically, let's say you have 1, 2, 3 and it's null, and second list, let's say you have 4, 5 and null. So as soon as your current 1 came here, null, your previous will be pointing here. Okay, your previous will be pointing here, and your current 2 will going to be here. So if your previous is here, your current 1 is null. So you know this thing that these values should come after 3. So you can simply say previous next is equals to current 2. This current 2 is holding all of the values of the list. So this whole list will gonna get on this back of this, like in ahead of this 3. So it will gonna look 1, 2, 3 and then 4 and then 5 and then null. This is going to be our answer. That's what we did here. If the current 1 is null, make the previous next as current 2 and return dummies next. Why dummies next? Because we don't want this whole list. Okay, we don't want this dummy node to be coming to our list. Our answer should only conclude only the final list, excluding the dummy node. So if you want to exclude the dummy node, you can do two things. You can simply return dummies nodes next, or you can just delete the dummy node and then return it. So we're gonna see that in our Leetcode code, but at this moment you can just simply return, this is our dummy node and this is what we need to, and this is the list we need to return. We don't need to return this, and this is actually the dummies node next. So this is dummy and this is dummies node next. Just return it, dummies node next. That's what we did here. In the else condition, else if he finds out that this current 2 is equals to null, that means this second list is totally empty now. Our first list is going to be our simply answer. So you can simply return dummy next. You don't need to do anything here. So this is our code looks like. This is going to be our whole code for merging two sorted list. So let's see on Leetcode how does it looks like, and let's make it work out. So this is our question on 21th question, merge two sorted linked list. So let's write the code for this. But first we're gonna declare our pointers. Let's declare our dummy node first. So list node star equals to new list node. Let's it contains 0 value. We're going to declare another pointer which is going to be our current 1, which will be pointing to list 1, the head of the list 1. So list another pointer, list node star current 2, which will be pointing to list 2. And a pointer which will be taking care of the previous node in the list 1. And this, at first, this will going to be initialized as dummies node next. Okay, now we're going to start our while loop, in which we're going to end the loop as soon as these both values become null. Our current 1 we need to run the loop till these are not null, and then our current 2 is not null. And here we're going to declare our second pointer to take care of the next node in the second list. Second equals to current 2's next. If current 1, so we're going to compare now. If current 2's while value is less than equals to the current's 1 next. If you found out that the value is smaller, then just simply assign it. So previous next is equals to current 2, and this current 2's next is equals to current 1. After that, we're gonna move our previous to where the current 2 actually is. So previous will gonna become current 2. So we did this. Now we're gonna make our current 2 move ahead in the second list. We discussed this before. Okay, this is the second list taking an account for the next node. So like in the this going to be the second, this going to current 2. If you shift this current to here, this is our second, and we're gonna compare now this. So we're gonna make this as our current 2. Okay, so that's what we did. Current 2 equals to second. In the else case, if you finds out this thing that the value of current 2 is greater, so just move ahead. Move the previous to the where there's a current, and move the current next. So move the current as current 1's next. So we did this. Now we're going to come out of the loop, and now we're going to check that if this current 1 is null, that means that the first list just became empty. If the list 1 became null at first, then you need to just return this dummies. Sorry. If the current 1 is null, then make the previous next equals to the current 2. If we're going to join the rest of the nodes of the second list to the first node, because the first is null now. In the else case, else if this current second became null, that means that the second list became empty now, you can simply return this dummies next. Okay, if the current 1 is null, you're going to make the previous next as current 2, and if this is true, then in the end it will going to return this dummies next. Okay, so this is our full code looks like. So let's see if it runs or not. Runtime error. Okay, so our runtime error is coming because we haven't actually took our edge cases. There can be two edge cases. Let's say at first our list 1 is empty. If it finds out that the list 1 is already empty, then you can simply return our list 2, right? And else if list 2 became empty, then you can simply return the first list then, because it's already sorted. In both of the case, let's say you don't have this list, you just have this. So you can simply return this, because if second list is not available, then this is your answer. If the first list is not missing and the second list is only the one that is given, you can simply return the second list. That's what we did here. We don't have to declare this as dummies knows next. We need to make previous as dummy, not the next. Sorry for that. So we can see our code is accepted. So let's submit it. So we can see our code worked, and hope you really understood it.